Potassium chlorate is a compound containing potassium, chlorine and oxygen atoms, with the molecular formula KClO3. In its pure form, it is a white crystalline substance. It is the most common chlorate in industrial use. It is used, as an oxidizing agent, to prepare oxygen, as a disinfectant, in safety matches, in explosives and fireworks, in cultivation, forcing the blossoming stage of the longan tree, causing it to produce fruit in warmer climates. Production: on the industrial scale, potassium chlorate is produced by the Liebig process, passing chlorine into hot calcium hydroxide, subsequently adding potassium chloride. 6 Ca, OH, 2 plus 6 centiliters 2 Ca, ClO3, 2 plus 5 CaCl 2 plus 6 hours 20, Ca, ClO3, 2 plus 2 KCl 2 KClO3 plus CaCl2. The electrolysis of KCl in aqueous solution is also used sometimes, in which the chloride ions formed at the anode react with KOH in situ. The low solubility of KClO3 in water causes the salt to conveniently isolate itself from the reaction mixture by simply precipitating out of solution. Potassium chlorate can be produced in small amounts by disproportionation in a sodium hypochlorite solution followed by metathesis reaction with potassium chloride, 3 NaClO2 NaCl plus NaClO3, KCl plus NaClO3 NaCl plus KClO3. It can also be produced by passing chlorine gas into a hot solution of caustic potash, 3 centiliters 2, G, plus 6 KOH, AC, a KClO3, AC, plus 5 KCl, AC, plus 3 hours 20, L. Uses: potassium chlorate was one key ingredient in early firearms percussion caps. It continues in that application, where not supplanted by potassium perchlorate. Chlorate-based propellants are more efficient than traditional gunpowder and are less susceptible to damage by water. However, they can be extremely unstable in the presence of sulfur or phosphorus and are much more expensive. Chlorate propellants must be used only in equipment designed for them. Failure to follow this precaution is a common source of accidents. Potassium chlorate, often in combination with silver fulminate, is used in trick noise makers known as crackers, snappers, poppets, or bang snaps, a popular type of novelty firework. Another application of potassium chlorate is as the oxidizer in a smoke composition such as used in, for example, smoke grenades. Since 2005, a cartridge with potassium chlorate mixed with lactose and rosin is used for generating the white smoke signaling the election of new pope by a papal conclave. Potassium chlorate is often used in high school and college laboratories to generate oxygen gas. It is a far cheaper source than a pressurized or cryogenic oxygen tank. Potassium chlorate readily decomposes if heated while in contact with a catalyst, typically manganese, 4, dioxide. Thus, it may be simply placed in a test tube and heated over a burner. If the test tube is equipped with a one-hole stopper and hose, warm oxygen can be drawn off. The reaction is as follows: 2 KClO3, S, A3O2, G, plus 2 KCl, S, heating it in the absence of a catalyst converts it into potassium perchlorate, 4 KClO3 or 3 KClO4 plus KCl. With further heating, potassium perchlorate decomposes to potassium chloride and oxygen, KClO4 or KCl plus 2O2. The safe performance of this reaction requires very pure reagents and careful temperature control. Molten potassium chlorate is an extremely powerful oxidizer and spontaneously reacts with many common materials such as sugar. Explosions have resulted from liquid chlorate spattering into the latex or PVC tubes of oxygen generators, as well as from contact between chlorates and hydrocarbon sealing greases. Impurities in potassium chlorate itself can also cause problems. When working with a new batch of potassium chlorate, it is advisable to take a small sample and heat it strongly on an open glass plate. Contamination may cause this small quantity to explode, indicating that the chlorate should be discarded. Potassium chlorate is used in chemical oxygen generators, employed as oxygen supply systems of, for example, aircraft, space stations, and submarines, and has been responsible for at least one plane crash. A fire on the space station Mir was also traced to this substance. The decomposition of potassium chlorate was also used to provide the oxygen supply for limelights. Potassium chlorate is used also as a pesticide. In Finland it was sold under trade name Fegabit. Potassium chlorate can react with sulfuric acid to form a highly reactive solution of chloric acid and potassium sulfate, 2KClO3 plus H2SO4 or 2HClO3 plus K2SO4. The solution so produced is sufficiently reactive that it spontaneously ignites if combustible material is present. In schools, molten potassium chlorate is used in the dramatic Screaming Jelly Babies demonstration. In chemical labs it is used to oxidize HCl and release small amounts of gaseous chlorine. Safety: potassium chlorate should be handled with care. It reacts vigorously, and in some cases spontaneously ignites or explodes, when mixed with many combustible materials. It burns vigorously in combination with virtually any combustible material, even those normally only slightly flammable. Mixtures of potassium chlorate and a fuel can ignite by contact with sulfuric acid, so it should be kept away from this reagent. Sulfur should be avoided in pyrotechnic compositions containing potassium chlorate, as these mixtures are prone to spontaneous deflagration. Most sulfur contains trace quantities of sulfur-containing acids, and these can cause spontaneous ignition. Flowers of sulfur, or sublimed sulfur, despite the overall high purity, contain significant amounts of sulfur acids. Also, mixtures of potassium chlorate with any compound with ignition-promoting properties sulfide, are very dangerous to prepare, as they are extremely shock-sensitive. See also, chloric acid. References: Chlorate de potassium. Chlorate de sodium, Fiche toxical now degree 217, Paris, Institut National de Recherche et des Arts. Copyright Curator. Copyright 2000. 4 pp. Continuous process for the manufacture of potassium chlorate by coupling with a sodium chlorate production plant. External links